Also, please have your calculators out just so that we are using it today. So please have them out ready and loaded. Yes.
Do you have a spare calculator?
I don't. Mine's dead. Yeah, I should charge mine too, but you need to charge yours, dude. Okay, let's just quickly recap what we learnt about yesterday, and then we'll start on today's topic. Yeah, so close your laptops, please. You only need your notes for this and your calculators. You won't need anything else. All right, so yesterday we quickly went through some of the newer content that I think I did get you guys to do this before the end of the term. But what we talked about, what we looked into is the shape of your graphs, so whether it's a box plot or a histogram or a dot plot, and determining whether the mean, the median, or the standard deviation is your best measure of center. Now, does anyone remember what are the three skews that we have when it comes to graphs? Yes. Good. So positive, negative, and approximately symmetrical or symmetrical. Okay. Those are the three shapes that we generally look into when we're working with univariate data. Okay. Now, does anyone remember as well, when we're talking about shape, there's a specific measure of center that is appropriate depending on the shape of the graph. So if your graph is skewed in some way, what kind of measure of center should we use? Anyone remember? We did learn about it in term one. Let's see if you remember. Yes, Tori. Good. So if it's skewed, median is ideal as a measure of center. But if it is approximately symmetrical, what can you use? The mean. Or in this case now, the mean and the standard deviation we use. Okay. You can also still use the median, but only when it's symmetrical can you use or should you use the mean and the standard deviation. Okay, and that's what we looked at. Now I'm going to quickly do this with you guys on my calculator so you know what you need to do. But for the questions, for the ones that weren't here, all we had to do with these is all of this was just a refresher on how to put this data in your calculator. Okay, so to do that, obviously you're going to go new and then do documents. But you need to open up one of these. Okay, so the Excel spreadsheet. Okay, actually I'll do that here. So if I go Control I, okay, it's listen spreadsheets. Okay, you need to open one of those up. Label your columns. Don't forget to do that, and then put your numbers in. Okay, and then once you put your numbers in, you go Control I. You're gonna get data and stats. Then you get your random dots here. Okay, let's see, Jordan. What do I need to do next from here? How do I organize these dots into a graph? Control, okay. And then? Okay, you need to make sure you're listening, okay? You don't need to press Control just yet. When you're at this point, okay, let's go back. All right, you're at this point, yeah? Control I, data and stats. You've got your scatter plot. Just go to the bottom where it says add variable and pick the variable that you're working with. Let me open that up a bit. Now your data will look like this, okay? You want to either make it into a histogram or a box plot. So to do that, you go menu, plot type. Okay, and we go histogram or box plot. In this case, let's just go histogram. Okay, now if you look at that data, okay, we can look at it and start talking about the shape. Same deal with box plots, okay? You can make it into a box plot. Now looking at the question back here, draw a dot plot. So we only need to draw the dot plot. Oops. Okay, leave it as a dot plot. That's fine as is. And then draw it. I'm not going to draw it here, but let's describe the shape. So if you look at the shape of it, what would you guys say is the shape? It's probably a little bit easier to determine the shape if I did make it a histogram. Sorry, a histogram or a box plot. But what shape would you guys describe it today? Now be mindful of where the median is. Okay, for this. So what shape would you describe it? What would you guys say? Any guesses? Any guesses? I would argue that it looks, even though the box plot is a little bit to the left, so you could be tempted to say that it's positively skewed. Look at the location of the median as well. I would say this data is probably going to be approximately symmetrical. Okay, and you can also look at the histogram. Okay, see where it peaks. It's kind of in the middle. Okay, So it makes a bell-shaped curve type data. So in that regard, we can talk about the distribution. And if I was to answer D, I would say that it's probably going to be good to use your mean as a standard of measure because it's positive, approximately symmetrical. These questions here, question C, what percentage of the students studied for 3 hours or less? Okay, 3 or less would be all of these. Okay, so if you counted, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of, and I think there was, I think it was 18 bits of data, if I'm not mistaken. Yep, 18. So 14 out of 18, put that in your calculator, times it by 100. 77.8. Okay, rounded to one decimal. All right, pretty straightforward. That's all we did for last session. Let's move on into the next one. Okay, and again, it's more of a summary as well. Later on, we'll go back, maybe later on in this session, we'll go back to the previous, the next topic, and it'll cover some of what we learned about there, but let's do this. So box plots and your 5-number summary is what we're covering today. So your 5-number summary and your box plots, they're all interrelated to one another. In order to draw a box plot, you need to have your 5-number summary. Now, does anyone remember what is the 5-number summary? Maybe you can look at that if you want to, but can you describe to me what does the 5-number summary represent? Yes, Anthony. Oh, but yeah, your hand up. Anyone want to take a guess? What is the 5-number summary? It's 5 numbers, as the name suggests, but what does it represent? What does each of the numbers represent? I want to ask Rocco, do you remember what the 5-number summary is? You can read here. Yeah, divides it into quarters. But what are those 5 numbers? Can you tell me what they are? 5 important numbers. Okay. What are the words? They're all here, guys. Good. Minimum, maximum. So what's the minimum? Lowest number. What's the maximum? The highest number. Okay. I'll go with what's the median? The middle number. So remember, in order for it to be the middle, put it in numerical order. And then what's Q1? Or first quartile? Anyone remember? It's the middle of the lower half. Okay. And then the third quartile or Q3 is the middle of the upper half. Okay. So that's all the 5-number summary is. A minimum, maximum, middle of the lower half, middle of the upper half. Okay. I don't know if you guys forgot how to do that, but make sure you remember because you need to be able to do that by hand, but your calculator will normally do it for you. Now, the interesting thing is with your 5-number summary, and we did talk about this, when you translate it into a box plot, okay, the box plot is a visual representation of all the values. And what it does is it splits all the data into quarters, as Rocco mentioned. So if you look at how it aligns, so the minimum would be there. Okay, the first quartile would be there. The median represents that line. The third quartile or Q3 is there, and then the maximum is that final data. Now, even though they are outliers, they would still be considered as minimum and maximum. So don't forget that when you're doing your box plots. But notice is what happens here is it splits each section of the box plot into quarters. So between the minimum and the first quartile, you'll find 25% of your data. Okay, do you see that? All the data in there is 25%. Same thing with between the Q1 and the median. You'll find 25% of your data is in there somewhere. Between the median and the Q3, same deal, 25%. Okay, and then the last bit, between the Q3 and the maximum is also 25%. So it splits up your data into quarters. Okay? And then from there, you can make sense of something. Sometimes questions in the next section will help us understand it, but it helps us to make sense of the data that you're working with. Okay, so be mindful of that. Your box plot splits up your data into quarters. I'll get rid of this so it's not confusing. Okay, let's continue. So let's actually do some of these questions as an example so it makes sense for us. So remember, your data is split into 25. I might actually put that here as well. Quarters. So from here to here is 25%. Okay, and then from the Q1 to the median is also 25%. And then from the median to the Q3, 25%. And then from the Q3 to the maximum is also 25%. All right, so it's split into quarters. Let's look at the first question. What percentage of students scored at least 52 marks? So minimum 52 marks. So if you look at where 52 is here, Ryan, can you tell me where is 52 on my number line? Have a look. Where is it? Where is it? Sorry? In the end? Middle. Okay, so the median's there. If you look at the values, it goes up by 2, I believe. So 52 is right in the middle of the median. So what percentage of students scored at least 52? So what you're looking at is how many people scored minimum 52 marks. So you're looking at all of this. So how much is that, guys? At least 52%. How much of the people scored at least 52 as a percentage? Anyone know? 50%, right? Because I'm looking at all of these guys and all of these guys. They all scored at least 52%. So 50% scored at least 52 marks. Okay? So half of the class or half of the Year 12 students scored at least 52. Nice. Okay? B. What percentage of the students scored between 10 and 75? Okay, so between 10 and 75, I'm looking at here, and 75 is about here. So all of this. So what percentage of the students scored between 10 and 75%? Tegan. Add up the percentages. What's 25 plus 25 plus 25? Anyone know? 75. Good. So 75% of students. Okay. Oops. Students scored between 10 and 75. Okay. Straightforward. That's why it's good to be able to understand that you can split up a box plot into 25% chunks. All right. Question C. What was the high score of the bottom 25% of the students? So bottom 25%, you're looking at all the kids that are the lower 25, so all this. So what was the high score of the person, or whoever it was, that scored in the lower 25%? Well, you're looking at all the values up to here. I think that's the 36. Okay, so if you look at the number line, highest score for the lowest 25% would be that value there. Okay, so 36%. Or 36 marks. Okay, is the highest mark for the lower 25%. All right, and then question D, if 200 students were surveyed, how many scored between 36 and 95? Okay, so if 200 students were surveyed, 36 and 95, if you have a look, 36 is over here, 95 marks is all the way up to here. So you're focusing on this chunk. Okay, so what's the percentage there, guys? How many students between, what's the percentage between 36 and 95? I'm going to ask Kira Lucas. Okay, what's the percentage of people who scored between, what was it again? 36, so here, and 95. How many people is that? Or how many in terms of percentage? Add it up. Add up the percentages. You got that, plus that, plus that. How many? 75%. So 75% of 200 students. So let's calculate that now. So now we do 75 divided by 100 times 200. 75, 100. Probably do it in your head, but 150. All right. Straightforward. Okay, the main thing I want you to get out of this is just understanding that your box plots are split into 25% chunks, and you can verify where each percentage is. Obviously, looking at the number line, but use your 5-number summary to identify, I guess, the limits of where those things are. All right. I don't think I'll do the other example. It's more or less the same thing, but Any questions with that? Everyone get it? Yeah, not too hard. All right, so go ahead and do those questions for the 5 number summary. And we'll do the other example later.